The underground engine, how a hydrothermal system works. We've discussed harnessing geothermal energy, but what does the engine that powers it actually look like? It's not made of metal and pistons. It's a massive natural system of rock and water, operating miles beneath our feet. To understand it, we need to look at three key geological components that work together like a natural pressure cooker. First, every engine needs a heat source. Deep underground, this is often a body of magma or mass of extremely hot crystalline rock. This is the burner on our stove, providing a constant, immense supply of thermal energy that heats everything above it. Next is the reservoir rock. This is a layer of porous or fractured rock like sandstone or fractured granite that acts like a giant rigid sponge. Groundwater seeps into these tiny spaces, filling the reservoir. The rock doesn't just hold the water, its structure allows the water to circulate. The final and perhaps most critical component is the cap rock. This is a layer of dense, impermeable rock, like shale or clay, that sits on top of the reservoir. It acts as a lid on the pressure cooker. Without this seal, the hot water and steam would simply rise to the surface and dissipate. The cap rock traps both the heat and the pressure, allowing the system to reach extreme temperatures. So, how does this engine exactly run? It's simple. Powerful process. Convection. Cooler, denser water from the surface gradually seeps down through fractures at the edges of the system. As it reaches the reservoir, the heat source warms it up. This hot water system becomes less dense and more buoyant, causing it to rise. When it hits the impenetrable cap rock, it's trapped. It spreads out, gradually cools, and sinks again, creating a continuous, self-sustaining circulation loop. This process creates two main types of hydrothermal systems: liquid-dominated systems and vapor-dominated systems. For liquid-dominated systems, in most cases, the immense pressure created by the overlying rock and the cap rock is so great that it prevents water from boiling, even at temperatures well over 300 degrees Fahrenheit. The reservoir is therefore filled with superheated liquid water. This is the most common type of system. The next is vapor-dominated systems, typically happening in rare conditions where the heat is intense and the pressure is just right. The water in the reservoir boils and turns directly into steam. This creates a dry steam field, a highly potent and valuable geothermal resource. So, the heat source, the reservoir, and the cap rock work in concert to create high pressure, high temperature system, a geothermal engine running silently and constantly. It's this trapped, superheated fluid that holds the immense energy that we could bring to the surface. Understanding this underground pressure cooker is the first step to harnessing its clean, renewable power.